Terminology we're going to talk about is rewind direction. Rewind direction simply means that we're putting the finished product in a certain direction so that it can be applied to what it's going to be applied to and not be upside down or not fit or something of that nature. And the rewind directions, we basically have 8, and I'll discuss that with you here in just a second, but we're going to look at the first 4, okay? Number 1 rewind direction is just like this roll right here. As you can see, when this roll's coming off, all of the print is upside down, okay? This would be a number 1 rewind direction, okay? Number 2 rewind direction would be just the opposite. As you can see, when this roll is coming off, all the print is reading right, okay? That would be a number 2 rewind direction. A number 3 rewind direction would run opposite of them. That means that the top of the lettering will be on the left-hand side when it's coming off. So if I wanted to read this, I'd have to read it from the right-hand side. So on the number 3, the top of the lettering is on the left-hand side, and the number 4 is just the opposite. The top of the lettering coming off the finished roll is on the right-hand side. Now, it's important that you get these rewind directions right and you understand them. Now, I had mentioned that there's 8. Well, there is. But as far as pressmen are concerned, you really are going to run 1, 2, 3, or 4. And at rewind, or the finishing, they generally will take and rewind it to 5, 6, 7, or 8 if it's desired. And simply put is, all it means is that the labels are ran the same direction, but they're rewound inside out. There are products that you'll get requests where the finished final product will be rewound inside out. These are your rewind directions. You need to learn them. You need to know them by sight. It's the most common thing a pressman and a finisher is going to deal with on a day-to-day basis. So make sure you get them right. Next term I want to talk about is one that you'll be familiar with as you work in a shop for a while. It's important for pressmen to understand because they'll run into issues of this dealing strictly with this, and that's corner radius. Corner radius simply is the arc or the curvature of the die cut. And we have a corner radius chart that will show you that arc or curvature. So when I have a customer who gives me a sample of a job and they want to reproduce this label, one of the most common things that you have to prepare for is what the radius corner is going to be. And as you can see on this one here, it would be a 1/8 dead on. And you use your radius corner chart to measure this out. Now it's important because if you're a pressman, you've probably experienced this before where labels will not strip properly. They'll want to pull off the liner, go up with the waste matrix, or whatever the case may be. A lot of times if your corners are not cut right, they won't pull. So keep that in mind when you're having trouble with a job or when you're ordering a die. Corner radius is going to be a big important part of your tooling, and make sure you talk to your die vendor to make sure that your corner radius is going to strip. Many times I've seen people demand a certain corner radius against their own die vendor's recommendation and then not be able to strip the job. So make sure you cover that and make sure yours is going to work for you. Next 2 terminologies I want to talk to you about are what really separate flexographic printing from the other types of printing, offset, silk screen, things of this nature. And that's distortion and dot gain. Simply put, distortion is shrinking an image in one direction only. If I take a product and put on my copier out here and I shrink it down to 80%, well, it's going to shrink the image in all 4 ways. It's going to just totally reduce it. Distortion is when I take an image and shrink it in one way only. And the reason we do this is because we want to print on a round cylinder which our product will grow. And what I mean by that is if I want this plate's final product to be 12 inches long, and I'm going to wrap it around a 96 tooth cylinder, which is a 12-inch repeat, if this plate itself measures 12 inches long, it's going to grow and be a little bit too long. So I have a distortion factor that we fit into the art or the graphics in the computer, and it'll distort. A 12-inch print cylinder will be in the neighborhood of 98-point-some-odd% of distortion. And that just means that it's going to take this product and shrink it in one direction. So when it grows, it won't be too long. Another big factor of distortion that you have to take into account is if I want to print a perfectly round circle, which I can't draw, so don't hold me responsible. But if I want to print a circle that's round, okay, and I start with a plate that's round, when I mount that plate around the cylinder, it's going to grow that way. So it's not going to print round, it's going to print oblong, okay? So what distortion simply does is it takes this circle and it stretches it in this direction before it prints. That way when it prints, it now takes that as it goes around and comes out round. Now, don't hold me, like I said, to my circles, but you get a good understanding that when you wrap a round circle around a cylinder, it's going to grow, okay? It's going to stretch in that. So distortion takes that into effect and brings in the focus to where you print the product the shape you want, and it predetermines what it needs to be distorted to. Thank goodness that the computers can handle all this, because I would be lost as an artist. The next thing that's big and important in this issue is dot gain. And what that simply means is if I want to print a dot a certain size, it's going to gain because we run a photopolymer plate, and when I push impression on it, it's going to squeeze out a little bit. The trick is to get as minimum dot gain as possible. But if I want to print a dot that size, I have to start with a dot that size. Now, to make that a little bit more understanding to you and you can see it better, let's say I want to print a dot that size. Then I need to start with a dot that size, because as I add impression to it, it's going to squeeze out. Now the trick to it again is to get minimum dot gain, because you want to have a good impression and you don't want to squeeze things out and you don't want to make things grow out of proportion, get your color right and stuff of this nature. But it's important that you understand that you are going to get dot gain and that you do have to deal with distortion factor. Them two things I see probably in graphics more than anywhere, mistakes being made. Probably third from that in graphics mistakes being made, I would simply say is trap, because I don't know if they don't understand the distortion or whatever, but it seems like we have an overwhelming amount of jobs in the flexo industry that don't compensate properly for trap. So if I was a graphics person, I'd try to help you on that, but I'm not. So if you are in the graphics field and you're watching this, or if you're a pressman and you're seeing jobs that seem to have some little trouble, these are issues you want to look at. Dot gain, distortion factor, and your trapping process. Them are three key products, terminologies that you're going to deal with on a day-to-day basis. Next thing I want to go over with you, something y'all are going to be very familiar with in the flexo industry, and this is our print cylinders, our tooth count, different terminologies of that nature you're going to encounter. Let me first start by saying we run 1/8 inch pitch gearing here, and what that simply means is that for every tooth on the gears we run, that represents 1/8 of an inch. So if I was going to run a job and its total repeat was 12 inches, that means I would run a 96 tooth. 12 times 8 is 96 tooth. 12 times 11, 88, so forth, so on. And on all your cylinders, they'll be marked. It's important that you stay in repeat. Now, if I was running a 2-around job on a 100 tooth cylinder, I could use 1 around on a 50 tooth. So if you do the math and you're running 3 around on a 75, you could run 4 around on a 100, so forth and so on. But the important thing is that your cylinders match up mathematically. The best way to ensure that is to make sure they're all on the same gear. That's the easiest way. A couple other things about cylinders. As you see before me, I have 2 different types of cylinders. I have what is a regular, I guess, chrome cylinder, steel cylinder, and I have what is a hard case cylinder. There is a big difference in them. The hard case takes a little bit longer to get and costs a little bit more, but it cannot be tore up. And I say cannot, I know everything can be tore up, But it resists razor cuts, it resists abrasions from day-to-day use, bumping, nicking, things of this nature. Much, much better cylinder. On the chrome cylinders and the steel cylinders, as you can see, they get lines cut in them. And if you look at your cylinder inventory and you see your cylinders have a bunch of lines cut in them, the odds are your registration is going to be tough to hold on a job. You'll probably even find yourself going back to the art department telling them that the job don't register right. And many times I have seen it where the cylinders are just so cut up that the ridges and the cuts in it going around have actually changed the OD of the cylinder. So now, even though you got 3 75-tooth cylinders, they may not be the same OD. That's critical if you're putting together process work. So for that reason alone, the hard case cylinder is much, much better. Another big common mistake I see people make is they'll get a press, and we all know that, especially in small business, but in business in any way, upfront costs are always significant on any job. And they'll get a job sent in to them where they need a 72 cylinder and they only need 3 colors. And they'll have a 6-color press and they'll order 3 72 print cylinders, run the job, and then 2 weeks later they'll get a 4-color 72 job, and then they'll order 1 more cylinder, and then next thing you know they end up with all 6 cylinders because jobs as they go along need and demand more ink lay down. And what happens is you get 6 cylinders that won't match, that won't register together well. And what I mean by that is if I order an 88 tooth and I've got a 6-color press, my minimum order is going to be 4. And I'll probably, if any way I can swing it in the budget, I would order all 6. And the reason being is because I know I can register 4 color process together. If these cylinders, 88 tooth cylinders made today, and let's say I'll order one again tomorrow or the next day, and especially if you order them from different vendors, it even gets worse. But even though they are tight-knit machine shops, you run a chance or a risk that they're not identical to each other if you don't order them at the same time. So it's important. Order what you can. Make sure you're getting groups of 4 if you're in process printing or any kind of prime label. Registration is going to be critical. Make sure you order enough cylinders to handle an average job. Like I said, it does not hurt to max your press out. Even if you're running a 4-color or a 3-color job that has multiple plate changes or product ID changes, you have other cylinders that you already have plates. So they pay for themselves in many ways if you get them in your plant and use them. The last thing you want to do is set up on a job you can't run because of your cylinders. Now, many of you watching this are going to say, well, my cylinders are cut up like crazy. What do? I can't buy them all. The best thing to do is a couple of repeats at a time. Send them to your die company. Somebody like Rotometrics will mic it out, tell you what they need to do, and many times they can buff them down and get them all the same size. If they're too far out, they'll tell you that too, and you may have to reorder them. But that's better than running product that'll be rejected or something you might not can get to register anyway. So remember, when you're dealing with your cylinders, it's important that you understand what you're getting when you're getting it. Probably the last unique thing that I like to tell people about cylinders, especially on our press, is make sure you get the wide gear. There are some die manufacturers, cylinder manufacturers who make cylinders still and will put the narrow gear on there for cost-saving reasons. At Rotometrics, you would have to ask for the narrow gear, and I don't even know if they'll put it on there. You need the wide case gear. That's all that this pivots on, so you need as much metal there as possible. It's important that you get wide gears. If you don't have wide gears, expect trouble and chatter because it's going to happen.